is a very simple chat application where you can run a bot which will try to signal the other party through a shared lobby where they want to talk with each other, and once the master picking up the message from the Turbot, it will join him in this channel, and they basically will have a conversation over one of these readers. The conversation will be encrypted and won't be visible to anybody besides these two parties. Okay, having said that, again, we will publish the code just after the end of this conversation, end of the talk, so you can guys go check it out in like 10 minutes, and we will have it. Okay. Good.
Okay, thank you. So now we've reached the last section of our presentation, the analysis, which also serves you as a kind of a summary. And we want to check if what we started with, the motivation for this research, and the Turbot that we created does in fact meet, and does Turbot have the merit that we wanted it to have. Okay, so we've made this table. I'm not sure how well you see it, but we have single point of failure issues like takedown actions and blacklisting, and blending in common traffic issues of what happens when you don't blend in, like corporate policy blocking your traffic, network footprint, and NAT issues, and how relatively each technology is dealing with each of these issues, and we want to see how Turbot is doing with each of them. In addition, we wanted to check two other things related specifically for Turbot. The first one is the communication efficiency, because Turbot relies on statistics. There is a chance that the invitation will be fined by the bot master, and there is a chance that it won't be fined. So we want to check if this model works in reasonable time. And also, we thought that maybe the security community would try to fight this botnet by specific means against this specific protocol. We will show you one of the things that one can attempt to do against Turbot, and we'll see if Turbot can handle that. So let's start. Let's start with the communication efficiency. Would in fact the invitation sent in this lobby space would be effectively collected by the bot master? Well, let's even do a very rough and strict calculation that each bot sends one invitation per hour, and the bot master checks every minute for an invitation, and that there are 10,000 bots in this botnet. And we have defined the lobby size will be composed of, say, 10,000 rooms. Then, in this case, each bot posts about 700 messages per month, and all the bots post about 7 million messages per month. So, after 1 month, the lobby space will be saturated with messages, and even if at this point of time the bot master will start to fetch messages, it will get a new bot and connect it every minute, because the lobby is saturated with new bots just waiting to be picked up. And after about 1 week, well, maybe not all, but the vast majority of the bots, according to this calculation, will be picked up by the bot header. So it seems that after, in this calculation, after 1 month and 1 week, most of the bots will be connected to the bot master. We've also created a simulator, and the results are actually much faster. After 1 week, it takes 1 week for both of the bots to connect to the master. So we think that with respect to that, the model is effective. What about corporate policy? Well, I'm just repeating what we have already said. Turbot is using HTTP. It doesn't use HTTPS, so we're not afraid that some organization or corporate will block us because they don't allow HTTPS. We're only initiating connection, so we don't expect any incoming traffic, so we don't expect any issues with respect to that as well. We were also concerned about the network footprint. Now, as mentioned, using HTTP is the most reliable medium to reduce the network footprint. It doesn't mean that it's not possible that Turbot will have a certain network footprint. For example, if it's the right in the user agent Turbot 1.0, then one could identify it for sure. But assuming that such mistakes will not be created, and maybe Firefox or Internet Explorer libraries will be used to make the traffic look completely normal, then we don't expect any problems with this, or at least choosing this medium, this HTTP medium, is the best way to reduce your network footprint with respect to any other used protocol. We've also